basically spent more than a year to figure out a way to avoid all these problems, such that it is always everything is always processed parallel. So the performance gain we got here is the largest we observed is 78 times more compared to one node. So and cost wise, it's not that different. So basically, it is as small or large, basically identical in terms of like computing size, but then its processing power is much more.
Today we're going to talk with Jesse, founder of NewMetric and one of the most underrated technical minds in Cosmos. NewMetric makes high-performance RPCs for the Cosmos SDK, and his work deserves a lot more attention. This episode is really niche and technical, but RPCs are super important for how users interact with the chain. So anyways, let's start the episode. In the most simplest, most succinct explanation, can you just explain Initia for us?
Right. So Initia is probably the most practical form of rollup launcher, such that anybody who wants to do something or build something on Web3 has, possibly all the options available within Initia, because Initia supports like all sorts of different VMs that are on the market today, as well as built-in bridges and oracles. So basically, it's probably the easiest choice you can make today to build a rollup. That's how I'd put it.
Yeah. So let's talk about, there's been this tweet recently on how chains are super expensive and how all these integration costs and all these not blockchain stuff like RPCs and block explorers are super expensive. Can we just go down the list of what Initia provides with the rollup and then how much would that cost and all those other details?
Right. So to say Initia, Initia is minimally speaking, it's just a sequencer, right? So every L2 has a sequencer, centralized sequencer. So each app owner runs their own sequencer. That part is technically just one node. If you think about it, that's just literally one software running somewhere in somebody's computer, and we, NewMetric, are trying to sort of be the outsourcing partner for that. So, well, when it comes to just running your chain, i.e., that one sequencer, it's pretty cheap. But then the cost, this is me talking after years of running or looking after the blockchain infra stuff. The usual expense, the parts that get expensive over time are actually not the chain itself, but the extra stuff. For example, like explorers or indexers. Any type of external infra that is not built in the sequencer itself is extra, such that you need to run an extra database and an extra job for indexing for your Blogger Explorer and everything. That kind of gets expensive over time because, well, not only the fee for these database stuff is expensive, it is also forever growing. If you think about it, so indexing is kind of meant to be, you store every single event, every single block from block one, right? Imagine you ran it for, I don't know, 2 years. Imagine how many blocks there will be, right? Especially when rollups are fast. So that's some terabytes of data, some terabytes, not like probably like 100 terabytes or something like that in the span of 2 years, which is becoming unexpectedly expensive over time. So, I mean, it's cheaper to start today because you don't have to deal with, say, validator rewards or any type of like upfront economic overheads. But over time, it definitely gets expensive because of these facts. And if you think about, say, like Etherscan, they're basically third party, right? You aren't building the Etherscan, but you are paying Etherscan guys to use the service. usually that part is very expensive because you're in this dilemma where you don't have the manpower or the resources to build it quite uh, up to the quality of what Etherscan today provides. But then, so you have no other choice but to pay them to use it. Um, what's great about Initia is they acquired this really kick-ass explorer called Celaton, right? So Celaton, basically, it has been the best Cosmos Explorer out there. Basically, Initia's plan, is to ship Celaton for every single L2 out there. So as a rollup owner, you no longer have to care about um, sorry, you no longer have to care about teaming up with Explorer teams or such like that. So it's much more painless in the long run. Yeah.
Yeah. So I guess that was a nice overview. Do you want to get into like your background, and then we'll talk about like how Initia uses the Cosmos SDK and more of the roll-up architecture stuff?
Right. So I'm coming from a signal processing background. So I used to do a lot of like LTE 5G, not the phone side, but then the base station side. So it's like real time, really, really fast. And when I say real time, it's like usually software that needs to finish within deadline. I used to do that and as a tech lead for 6 to 7 years, and then I moved into crypto space right after that, around 2017. My first chain to use was Ethereum, and then I sort of briefly ran a Korean foundation here in Korea for Tezos. There's a blockchain called Tezos, and then we didn't do quite well, so I then went to Terra TFL, now defunct, but I did a lot of infra stuff as an infra lead at TFL, as well as some part in Anchor. If you look around the internet, there's a video that's calling me like lead dev of Anchor. That was only partially true. So, yeah.
Yeah, nice. So then how did you get into, I'm assuming you started NewMetric first and then got to Initia, or explain that relationship?
Right. So we aren't technically a part of Initia. We're just close friends. So I know, Don and Stan as like close affiliates. Um, and what my forte is sort of like tooling, like automation tooling, or finding a faster way to do something. For example, RPC. So, but the in-house dev team for Initia sort of didn't really want to care about them because ideally they want to focus or their like firepower into developing the most amazing software on this planet. So we had this agreement where it's basically commissioned work, but we help some part in Initia such that it's either easier for people to use it, or it's better in terms of performance and everything. So we do a lot of those researches and actual implementation.
Yeah, so you at NewMetric do all the tooling. You guys run the nodes yourselves, or right?
Right. We run our own nodes. Yes.
And I guess let's go into the price of all that.
Right.
Is it really just $900 a month for like everything?
Uh, and so that's just a base cost. I should say we're not really making too much money off of that because like 800 or 900 it may sound too cheap or too expensive for depending on how sort of experienced you are in this price tag for computing power sort of market. But basically, what we want to do is make it easier to start with rollups for anybody, like make it easier for everybody to start with rollup. And I think I quite like the idea of like how Initia is like doing their stuff. So um, we are essentially sort of not losing money, but kind of trying to provide it for like as like a community service, really. And that within that 800, it really just comes with the basic sequencer. And on top of that, what we um, provide as an add-on is what we call Mesa. So internal product name is Mesa, which is our sort of hacked version of Cosmos, which runs way faster when it comes to RPC serving. That depending on the usage, that cost for that might be a little different over time. If you actually have like a million users, and it's obviously going to be kind of expensive. But I hope that makes sense for the users to pay for the service at that point of time. Um, and we also have this tool called Cradle. So Cradle is similar to Foundry from Paradigm. So basically, what it allows you to do is fork uh, fork a running chain, i.e., your L2 network, right, into a dedicated testnet. So basically, it copies a snapshot in some point in a time, right? And then it only preserves sort of states from that point on, upon which you can send test transactions and etc. What that allows you ultimately to do is test in prod, right? Done really well. Because one problem with crypto testing is like everybody wants to likes to use testnet, but testnet is not never really correct, like compared to mainnet. Mainnet is where all the juices are. Mainnet is where all the users are, funds and all the hacks and crazy stuff is happening. So you kind of want to test on mainnet, but testing on mainnet is, it's not practical, right? So what you want to do is a perfect simulation of mainnet. Cradle basically supports that. So within that add-on package, we also support that. Yeah.
Yeah, I guess we're going to talk into the more like RPC side of things.
Right. Right.
So an RPC is just like a full node of a Cosmos chain that then like,
Mhm.
gives you all the state. But you guys said you guys like have your own hacky version of this. Can you like talk about like the amount of, I guess,
Mhm.
request an RPC has, and then like what have you guys done to
Mhm.
like scale this out?
Right. So this technology we are selling right now, the code name Mesa, is actually something I built back at Terra. So Terra was a really popular chain. Like it was like ranked 9, and then it was probably second most active DeFi platform. So as an infra lead, like literally I was the guy behind the desk looking after all the infra stuff. So, such that people or users can always have access to their funds and, usability in general. Um, the peak request count I saw was about 2 million requests per second. So that's equivalent to 2 million users making or connecting to, say, Anchor website at the same time, right? All at the same time, which is no joke, right? It's very, very hard. Like Ethereum is talking about 100K TPS. It's basically 20 times more than that. Obviously, it's not transaction, but still, right? Query side is so important. Uh, One thing that Cosmos is or has been bad at, I don't know if it's going to change in the future because they have V2s and everything coming up, which seems to have fixed all these problems. But the RPC performance is kind of bad. Bad because, if I were to explain it really easily, any Cosmos full node is able to process one query at a time. So, if a query takes 10 seconds, right? Everyone else's query is basically blocked out for 10 seconds. That means if the node is really crowded, i.e., there are suddenly too many users trying to use the full node or your web app, your nodes sort of slow down, right? You have, well, if you don't have any like hacky solutions like us, what you normally do is what we call scale out, i.e., spinning up many more nodes, right? But the count is you know, is 2 enough? Is 4 enough? Is 10 enough? Like you don't know, right? And even if you have 10, the problem still persists, right? Because like what we usually do, engineers usually do, is what we call load balancing. So, when there's like stream of requests, you sort of um, scatter them across all these 10 nodes, right? But then each and every request takes 10 seconds, then you are basically blocking out 10 nodes at the same time. So we don't want that. So the tech I developed back at Terra and still sort of researching at NewMetric is a version of Cosmos SDK that favors what we call concurrency. Concurrency is a metric of how parallel your software can process requests at the same time, such that one request comes in, it doesn't have to wait for that first request to finish, but you can straight away start processing the second one, etc. So in order to achieve this, not only we had to hack, basically like flip the whole Cosmos SDK upside down. So if Cosmos SDK usually processes this way, we are basically doing this way, which means we basically touched every single point in Cosmos SDK where it causes potential performance problems, as well as kind of rewriting the um, underlying database. Most of the performance bottleneck usually comes from database, and then you're trying to synchronize, some things around it. We basically spent more than a year to figure out a way to avoid all these problems, such that it is always everything is always processed parallel. So the performance gain we got here is the largest we observed is 78 times more compared to one node. So and cost wise, it's not that different. So basically, it is as small or large, basically identical in terms of like computing size, but then its processing power is much more. So some teams are using it, like Injective or other, like Celestia. Some teams are using it and people love it. One good example is like, I don't know if you remember, but the first day of Initia testnet, Initia initiation one, basically as soon as the web app went online, everyone sort of obviously rushed to claim their whatever, on play around the web apps and stuff. Basically, the like the cluster of nodes that the Initia team had was nowhere near enough to process all this load, right? But I thought that was going to happen. So what I did is, about 4 to 5 hours ago, or 4 to 5 hours before the actual launch, I was like, let's prepare for the actual testnet so that, we, in the worst case, we can switch to our nodes, right? So, I literally walked down to NHS office, which is about 10 minutes from here. And then sat down, hey, are you guys having problems? And then like, yeah, why don't you use ours? And then, yeah, let's do that. And then it then started working. So it's kind of it's you need it when you need it, right? And the peak request I saw at that time was about 130K requests per second, which was a lot. Um, so yeah,
Yeah,
that's the story of it.
that's good. So I guess with the RPC side of things, so you made this really
Yeah,
performant RPC
hmm
and like made all these modifications to the Cosmos SDK. Can
right.
you tell us why like you can't just apply those to like the full nodes themselves? What's the difference between like the requirements of a validator versus an RPC and why you can't apply the same efficiencies to it? Or can you?
Um, Technically you can, but it's sort of the code kind of has diverged enough to call it a different software at this point. Basically, at this point, it's like it happens to be a software that is compatible with Cosmos in a way, such that it is able to serve RPC queries, but really internally it's all different. Like it's very, very different. So upstreaming, this is what we call upstreaming. So basically applying our patches back to Cosmos ACK base code is kind of like I don't know if there's any incentives for us to do that, especially if we're running this as a business, right? um, but there's a part of me where I think the like NewMetric as a company shouldn't exist in the first place. Like, software just should be good in the first place. So there, there's no need for a third party RPC provider, right? So I actually did think about upstreaming like about a year ago, but then I were like, hey, we're losing our business mode, right? Those who use us, pay to use us, do so because they need a faster version of it, and then like why give away the great features of it? Secondly, it's kind of not possible to merge it back to base Cosmos at this point. Yeah.
Yeah, so now we have like this new SDK version, and I guess we're going to talk later on like your experiences with the Cosmos SDK. Like that's like
Hmm.
my favorite part to
Yeah.
talk
Yeah.
about.
Yeah.
So I guess like let's talk. Do you regret, first of all, do you regret taking this decision now that like they're sort of now making these new versions, right? I think it was the right decision.
No, I think I like it. Well, basically Marco, the product owner of the Cosmos SDK, basically we had a couple or maybe 3 to 4 chats about about the improvements that we made, and then it made a lot of sense. And any engineer who's in like good faith and sound mind would do the same, right? Because RPC problem is very real, but there are other problems as well. But RPC just happens to be one of them that has like a real world impact every day. So fixing it uh, would have happened anyways. And I just think that NewMetric, we've been 2 years. Um, we learned a lot, and that is sort of giving me hopes in, say, not just Cosmos, but in like Rollup in general, because as rollups are supposed to like broaden the reach of Web3, like you're gonna see like tens of thousands of new chains popping up every day. Um, some of them are really going to be like in need of such a solution, right? Whether you like it or not, eventually. So having this kind of tech um, is definitely meaningful. And honestly, like it's not the code itself that matters to me. It's the knowledge that I've gained um, down the road, because I basically had a very vague idea of how it should work. But right now, if somebody asks me like, how do you scale up RPC? I can talk for like 4 days, right? Like what are the specific points that might go wrong? This is the point you probably want to look into and stuff like that. So that knowledge can translate into something bigger in the future. So you're kind of right. Like I kind of regret that in a we're sort of in a bad situation where the new version of Cosmos might basically render us obsolete, right? So, but at the same time, we're preparing for something else. Yeah, we want to do something about L2 as well, especially um, more like um, fun ways to build blockchains or easier ways to build blockchains, just like how we are helping Initia. We are thinking more in those terms and basically generally making the tech more accessible is what we do mostly these days.
Yeah, I
Yeah.
guess can we talk more on like your experience with the Cosmos SDK, just like more in depth? Just how has it been over the years, and like the newer version, and just like the
Right.
day in the life, the experience of working with it.
Um, so I don't really know about the newer version yet because I hadn't had the time to check out the code just yet. But basically, the Cosmos as we know today has been quite the same for like last say 3 to 4 years. I mean, obviously there's some improvements made, so for security reasons or performance reasons in some part. Um, What excites me is Cosmos is probably the only solution today that lets you customize about everything in your blockchain, right? Think about EVM, think about what do you call it? The move. You are sort of confined in this very strict um, like rules and constraints that these frameworks sort of impose on you, right? So you cannot escape what EVM expects you to write the code. But then compare that to Cosmos. Cosmos is really a bunch of Go code, right? It just happens to be a set of codes, random codes. Like I should really say random because anyone can write whatever code as long as it adheres to the Cosmos standard of what it thinks of a token, what it thinks of a account, what it thinks of like inter-module communication, IBC, whatever. IBC really is just another set of code as well, right? That is limitless, right? Like you can make anything you can think of without being constrained by these VMs. So for that, I think it's great. I hope it was a little more flexible, such that well, comparatively, it's less constrained, but like constraining, but it still kind of is. And I am these days, I'm thinking like how to reverse it, such that a very minimal blockchain framework that gives you 99% control, like even lets you define how a transaction looks like, how a block looks like, or execute transactions in asynchronous manner or whatever. Like just do whatever you want to do. This whatever software that runs underneath, which is relatively minimal and stealth, is what makes a blockchain. So you just write whatever you want to like. Write Discord if you have to something, but just make it blockchain, right? That's what I'm most interested in. And Cosmos definitely has pushed me into that framework of thoughts because that freedom is something I would never give up as a developer. And I think right now EVM dominance is a thing, and there's a reason for that. But I think in the future, where there's a lot more like more fun apps, as in like more non-financial apps, I should say. You want that sort of freedom and control. And I think Cosmos is going the right direction. We are trying to do something about it too, not necessarily in Cosmos, but some other arc. But yeah, but it's freedom that meant sovereignty by code, right?
Yeah. I guess, you talked about how like all this code is different. How does that affect sort of building RPCs? Do you have to have like, custom versions of what you call what Mesa? I'm sorry.
Oh yeah.
Do you have to have custom versions to meet these custom versions of SDK
Uh,
chains?
Kinda, but not really. So we have one set of code that is compatible with every single chain out there. Today I think we're compatible with 26 chains. And I'd say 20 um, out of this 26 chains are relatively vanilla. Like they don't really hack the Cosmos SDK itself. They're just a bunch of modules that are glued together. So to us, they're not really that different. But there are chains that are really, really different. Like, Celestia is like really different. Say is like I would say it's not even Cosmos at this point. Um, but like as a CEO, like the last thing I want to do is basically create a separate set of codes for each and every chain just because they are different, right? Like what I want to do is create one set of code that is kind of compatible to all these chains as long as they're using Cosmos and Comma 50. And that's what we kind of optimize for. I wouldn't say we're perfect for that, but I think 96%, I'd say, we just use the same code for everybody. Yeah.
Yeah, can you talk about the elasticity of like an RPC? because you talked about how, one RPC can sort of can meet, the same requirements as 75, or, you said 78
Yeah,
replicated
78.
RPCs.
Yeah, yeah.
So could you talk about, can you have one RPC for multiple chains, just Cosmos chains? And how is that different? Can you have one RPC for multiple rollups? Could you just talk about the elasticity and how they can,
Right.
yeah.
Right. So elasticity, um, so in my book, elasticity means your system sort of scales in and out depending on the requested volume, right? The volume thereof, right? So if there's like 10,000 people accessing it, you obviously need more than, when there are 10 people accessing it. So it really comes down to cost optimization. Like you don't want to have 100 nodes just because someday you're going to have 10,000 users, right? You want to be elastic. And the thing that most people don't really talk about is, yes, if you have a in-house DevOps team, you can sort of scale out your nodes like ad hoc, right? Adaptively, but usually it's too late to have scaled up to 10 nodes, but then all the users already, hit the slow nodes, they're like, what the fuck doesn't work? Like, I'm like, not use it, something like that. They quit, right? So my version of elasticity is on time, also cost effective, while fast. Like that's those three words don't really come into the same sentence like all at the same time. But um, that level of optimization is what we do. Basically, we don't just put things out and then hey, say it works. What we really like to do is nerd snipe um, into the tech itself, such that we would spend a week to save 1 millisecond. That's a good explanation. And rollups, right? So rollups are technically many, many, many more chains of say I'd say relatively small, but some could be large, right? If rollup the end goal is there is only Arbitrum, there's only Optimism, there's only Base, then it's potentially bigger than L1 RPC. But on the other end of spectrum, it might as well be just many 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 small chains that are running individually, right? So the important factor here is like how easy it is to sort of um, spin up a set of RPC that is compatible with their chains, their rollups, as well as being cost effective. Because there's some base cost that goes into like maintaining the minimal possible set for a chain. Um, you probably don't want to scale set up too many of the nodes at the same time just because there are 200 rollups, right? When there's no actual user. So finding the right balance between that, where the number of rollups and the cost, while being ready to scale up when there's a fire, is important. And that level of optimization is quite special because if you think about it, like all the nodes or blockchain, what we call blockchain softwares, are just literally one program that somebody runs in a computer. How ready is it? Like it takes minutes or hours to copy one node to another. Are you like flexible or elastic enough, right? Yeah, that's something we gotta think of. Um, and it's not really being talked about by, say, engineers in this field because that's not their primary question that they need to answer, right? Like, everyone's like sort of obsessing over how fast the consensus is, how fast the execution model is, how parallel. Yes, these things are important, but somebody's gotta like think about RPC, right? Yeah.
Yeah, let's talk about the user experience. So
Hmm.
like, if the RPCs don't exist and like you can like hit refresh and like your money's gone forever,
Yeah,
is like how it feels.
right.
Could you talk about, so like I'm on my machine, I'm like refreshing. How does my laptop connect with an RPC, and then how does an RPC connect with the network itself?
Right.
So can you just like go through that flow?
So from your laptop, you obviously hit the internet. So internet, usually we connect it to things by addresses like DNS, what we call DNS, domain name services. They get resolved to what we call IPs, like IP, the numbers. That's like a unique address assigned to the very computer that's running the node. So your packet hits that computer, and within the computer, it knows where to route that packet internally within the computer. Like ultimately, it hits the node software, and then when the node receives your packet, it then sort of parses or tries to understand what your request is, i.e., your balance or some contract's balance or whatever, and then what it usually does in blockchain context is it actually goes into VM itself, whether it be EVM, Move, Cosmos, doesn't matter. It goes into the very code that that constructs the blockchain itself, the program, and usually there's a small function and program function that gives you a piece of information from the blockchain state, usually the latest state, right? Um, you know, in AVM, that's part of the contract. In Cosmos, that's part of the some what we call courier. Um, so when it's done computing that response for you, it then sends you the response back to you, so you'll be able to see it, right? Um, that's what happens. What was the second question?
Oh, and then so I guess you went through the
Mm,
laptop, the user to the
yeah,
RPC.
basically end to end.
Now, the
Mm.
RPC to the actual nodes
Right, right.
themselves that are
Ah, okay,
implementing
okay.
this.
So RPC is nothing special. It's just a web server component of a blockchain. So when you have a full node in sync with the rest of the network, you can use that as an RPC, right? So RPC is more of a like not a special type of node. It's more of a specific function of a node, I'd say. Um, so as long as you're running a full node, you can use that node as an RPC. What it usually does in blockchain context is um, I'm gonna assume that we're not a validator or miner, right? You happen to be part of the network, the consensus network, but then you don't vote for the consensus. You just listen to consensus results because you don't have the voting power, or you're simply not interested in voting for blocks, right? So whenever a block is made, i.e., the validators or stakeholders are done agreeing onto a globally agreed upon order of transactions, i.e., block, you receive block and run it. Run it as in you have some state for like resulting state from the past block or the entire history of a block. So let's say this is block height 100. And in the consensus, the validators have agreed to have, hey, this is block 101, right? You receive it, you run that block against your local state, so it sort of transitions into the next state. So basically, your full node is an RPC. What it does is receives block from the rest of the network and apply it. To your own state, see if the resulting state matches with the rest of the network, and serve the latest data as an RPC node. That's I'd say what is happening under the hood.
Yeah, that's so. Whenever a user, let's say, requests to see their balance, they hit
Right.
the RPC,
Right.
and then let's say, okay, I want to send money. Does that transaction go to the RPC and then the RPC towards the full nodes, or just the user's transaction directly goes to the full nodes or the
Um,
validators. I mean,
so usually what happens is, I'm assuming you as a user are using wallet, right? So wallet Kepler or whatever. Kepler, all these wallets are almost always connected to a node or many nodes at the same time. They may or may not be validator nodes, but there are only two types of nodes, like validator node and full node. Software-wise, they're the same. It's just whether you're participating in the consensus or not. That's the difference, right? Um, so when you click submit or confirm, what happens is your transaction gets sent to a node somewhere that's part of the network, right? And then from that point on, what happens is it broadcasts, as in like to everybody in the network, your transaction, right? So such that everybody in the network now knows about your transaction, eventually hitting uh, or eventually going into the inbox, what we call mempool, right? Mempool, eventually hitting the mempool of the proposer of that particular height, let's say 100, 102. And now it's proposer's turn to, hey, this is what I think 100-second block should be, right? If your transaction has ended up in the mempool of the proposer, then your transaction is in. If it's not for whatever reason, like I don't know, somebody in the network dropped the transaction for no reason or like censoring or network outage, then it might not as well just end up in anybody's mempool. Then transaction is lost. What you do is you retry. But first, it hits any node, including full node, validator node, doesn't matter. It's just what wallet it's connected to. And then that node is going to propagate that transaction to everybody else in the network.
yeah, that's good. And I guess another question is, so you guys are running your RPCs in Korea, right? But
Yeah,
how much does that matter when it comes to sort of global latency of internet pings or
right,
packets?
right. So
Does that matter?
it does
Does
matter.
that matter a lot, or does like the code matter first and then sort of global latency? Does
Uh,
geo distribution of RPCs, how much does that matter? Just all those questions.
I'd say latency is something you cannot overcome. So, like, even though we're in Korea, we don't run our service in Korea. We tend to run in all three continents. So, one in Europe, one in the States, one in Asia, right? So, we have like a good geographic coverage for anyone who might want to use it. Reason for that is, like you said, to reduce the latency. So, no matter how fast we are, if the say internet speed between you and our server is too slow, i.e. too far away, means nothing, right? So it may take a second to um, usually second is a good enough of time, but what we look for is global latency below 2 to 250 milliseconds per query. I think that's a good enough of metric. And for that, we tend to run, in many different locations. We don't like
Yeah.
we cannot just make internet go faster, right? That's out. That's not something we can do. So better way to do is just put our server close to you, right? And then if it's faster, then it's better.
Yeah, that's good. I didn't know that. Another thing, let me think. I forgot my question. Is there anything else you wanted to talk about individually? Anything I didn't like cover or sort of common misconceptions?
um, well, this is where I got crazy, but L2s are not extension of L1. I don't know, like I don't know how deep you want to go in this rabbit hole, but that's what I've been like. I spent a lot of time like philosophizing these days about what or where the Web3 industry should go in the future. As in, like, the reason why I like Initia is they try to be the best tool for anyone in the future who might be interested in Web3, right? And if you think about Web3 as a whole, it's like, A16Z issued this report about a week ago, and about 90% of all the applications in Web3 are some form of finance, like as in like DeFi, stable, then there's a bridge, there's infra. That's great because like Web3 is inherently optimized for that, right? Like just borderless payment starting from there. I think we are in the process of defining what this internet money is, right? I.e., having like, I don't know, like DEX or a new way to have stable coins and everything. But what I keep reminded of is like, is it just all about financial stuff, right? Because I think it's been a while since people have started saying Web3 needs to have like more useful apps or fun apps, but it still seems like we're all focusing on this financial aspect, which is great, right? We're setting the foundation. Now foundation is set, right? We got to think of what to do on top of it, right? Because all this value we created is only better if it's put to a better use. Right now, I think with all these protocols, we are optimizing for move or efficiency of value rather than creating new net positive value. Because like if you think about what DEX does as a utility, it facilitates a trade between token A to B, right? But it doesn't quite add the token C minus the governance token. But I think that's what is like, and I don't know, like it's like the more we delve into this financial aspect of it, the more we're pushing away all the future prospects of like a fun application into Web3. Whereas these applications could really make a good use of Web3-ness in their application, i.e., if it's anything like equity, it's always better because it's like having the option to go to market on day one, like as soon as you launch your application or whatever, like and all the market primitives are there. Everyone is like willing to trade and then pump it to 1,000, whatever. Like it's crazy market, but it's efficient market, right? And I think we should do a bit more than just being efficient, right? Like just bring more value so that that efficiency is like it rises to a level that's unheard of, right? I think that's the true value of crypto. And rollups, I think, are meant to carry that out. Like, think about it. It's a way to create new chains. And then when you have, why would you even want to think about having a chain rather than a set of smart contracts, right? Smart contracts, Ethereum L1, Solana move has been great. But then why, like as a builder, would you want to choose rollup, right? It is because you want more control, as in like probably you don't want to care about gas. You don't want to care about, I don't know, transaction. You want to have some more way to like um, like fabricate your own application, but still retain the blockchain-ness, i.e., the token or interoperability, composability, everything. So I think it rollups in that sense, rollups are much more than just making Ethereum faster. It's just new ways of making blockchains. I think most of the rollups out there, including Initia today, although they are trying to like sort of do the have the escape velocity, and I'm helping that, are mostly reusing existing tech such that it feels just like Ethereum. Like, is it a good thing? I don't know. Like, like so I am philosophizing a lot in that regard as to what we could do now that at this point, after 2 years of rabbit holes, of like fixing a software that's not necessarily built by us, right? So like we had the chance to spot the points that could potentially make blockchain a little more freer, not a little more, like way more freer. So that's, yeah, I hope that makes sense.
Yeah. So like, networks like Ethereum isn't everything, and like the finance stuff isn't everything. And I guess like rollups now, like, I also agree. I don't think they're extensions, network extensions.
Mhm.
I think like a rollup is more just like a verifiable server nowadays.
Right. Exactly.
And so
Mm.
uh another thing is when it comes to applications, I guess we're all using like Move and EVM
Right.
and I guess Cosmos. Could you
Mm.
talk around sort of the architecture of Initia? I also want to see like more boring VMs like SQL. Like I think like more developers are like used to like boring VMs and
Boring PMs.
boring
Uh,
tooling
right,
essentially
right,
like Java.
right, right. So Cosmosm is a little different, but I'd say EVM and Move are quite the similar. So they tend to be what we call a like closed VM, such that it is a full VM. It doesn't allow you to talk to the outer world. It just doesn't allow you to do that. Like it sort of sandboxes everything in it. And the first iteration was EVM, and then Move sort of wanted to um, make this asset representation on code better than EVM, because how EVM represents somebody's value is literally one slice of data on memory that this address has this much of token, right? That's it, right? So that's how it represents token. And I think that simplicity without like proper capability management has caused a lot of problems. That's why Move is like um, this is asset first, and then as long as you're the holder of the asset, you also have the capability that you can use in the code. But gist is, it's just a bunch of code, right? What Cosmos allows you to do, like I said earlier, it's just a bunch of Go code. So as long as there's a code runtime for these VMs available, you can have them on Cosmos. That's how, say, Initia has mini EVM or mini WASM, right? So literally they glued an existing EVM get on top of Cosmos as a module, right? One module. Move is the same. So Move part, as far as I understand, it's kind of glued the similar way as how Cosmosm is glued on top of Cosmos. But really, there is a set of Rust code that's written the named Move VM. So as long as that code is there, you can run it on top of Cosmos, right? Well, Cosmosm is a little different. It's not really a language itself. It's just a clever use of what we call WASM. WASM is more like a general embedded environment that technically any language can be WASM. It just happens to have chose Rust as its reference language. So all the Cosmosm languages are written in Rust, and what it does is it exposes you a set of functions that lets you talk to the underlying Cosmos. Like there's DB, there's database, there's whatever, like bank modules, whatever modules in Cosmos. How this compares to the boring tech, I'd say, or like I should say, why we have come to this point where we had to develop new VMs, right? Why? What were the things that in the boring VMs that didn't qualify as the proper VM tech, I mean, blockchain tech, right? I think blockchain technology or teams have tendency to prioritize security over freedom, let's say, because what blockchain requires the property that is most required is composability, and then when it comes to composability, you need to be able to trustlessly know that the other contract is going to comply to or is doing what it says it's doing, right? So that level of atomic, compatibility, I should say, is required. So only then your contract can talk to another contract, like through the means of ERC20, or knowing that, hey, I have this set of code, you have this set of code, we are compatible, so we know we are compatible without even seeing it, right? So that level of, I'd say, closed knit control flow, I think it was a necessary property. But in the sense of in the world of, say, rollups, right? I don't think whoever is willing to build in rollup are willing to do that because they can use EVM but faster. I think they want more, right? Think about what Monad is doing, right? Parallel EVM, that's great. Is it impossible to have parallel EVM code-wise? It is possible. Like, it's a matter of choice. Like, if you want to reverse such constraints of a VM, so you can have these like locked away properties, you don't have a choice but to fix it yourself or change it yourself. I think those controls are what intrinsically like rollups are for, because you can do that if you want to. If you're building on, say, Solana, you cannot do that because network pretty much requires you to behave a certain way. Now that's another thing. So you can take SVM, fix the shit out of it, and then do whatever you want to do. Obviously, that puts the burden of security and basically program that works correctly onto you, right? It's now your job to make it secure. But if you think about all the other applications out in the market, that has always been the case. So like, I don't know, the more I think about it, maybe bring back the Boomer VM or Boomer Tech is a good addition to blockchain, as long as you can somehow make the minimum set of blockchain security there, right? As in token, this token owned by somebody else cannot be spent by somebody else, right? Like, as long as those rules are intact, I think it's going to be fine. And I think it's pretty evident because, more and more teams are doing what I call ALO, AOLO. That stands for Asset on Chain, Logic Off Chain, right? Why do that? Like, because VMs don't allow you to have that part of the logic that you wish to be part of the blockchain, but it's not really feasible today. So you decided to, do it off chain. Why should that be the case? Well, obviously, I think the research has been has gone into like making EVM better, making MoveVM better, making Cosmos better. I just happen to think it's about time to bring back the boring tech and give you complete freedom.
Yeah. Yeah. Another thing I think you touched on was like Initia has like a Cosmos SDK optimistic rollup.
Right.
And then they'll put like the EVM inside a module and then run it there.
Right.
Same thing with Move.
Mm-hmm.
Could you also have a single, initial rollup with like 2 VMs?
Yeah.
Like, why would you want or not want that? Or just like,
is that
possible?
I think Say chain has the EVM and Cosmos at the same time. So it is possible. Like, it's just, why would you do it kind of question rather than can you do it question. It can be done. You can technically have like SVM, EVM, Move, Cosmos all at the same time. Yeah.
Yeah. And then also another question is, because you have like these like individual rollups that you can run RPCs for, is this like way easier and like way more, I guess, like, modular? It separates the concerns versus having like an RPC for Solana. Like, how do those two markets differ? And like, how hard is it to run multiple rollup RPCs versus like one fat RPC for Solana? Like,
obviously, like as like from the tech perspective, running one fat RPC is way, way, way easier. It's just, less things to care about. Basically you can automate the shit out of it such that it, you get to optimize for one thing. But then if it's like 10,000 chains, I don't know if I can do it yet, right? Um, but there will be somebody, like, I don't know, it's gonna be me, that automates all of this so that there's a conduit already, like other RAS providers who basically do this, just not for Initia. They're doing it well. And then really it comes down to how automatable the process is. And obviously you got to think about the cost benefits of that. Um, yeah. So it is kind of, just matter of automation and then how automatable your actual solution is, in like in comparison to all this number of L2s growing every single day.
Mm-hmm. I would think that the Solana RPCs would be more harder because like Solana has so much like data and you're like such a big chain that's very fast.
Mm-hmm.
So I guess it's the opposite. It's just like more simpler. Is that it?
I'd say it's definitely, it's definitely going to be more points you need to look for, because like you said, it's like much faster and it has a lot of data. But that isn't to say smaller chains are any uh, like easier to run. Like the risks there are pretty much the same, right? At the end of the day, you're just running a software. So it's not like just because the chain is faster, it's likely to, it's likely to break sometime. If that was the case, Solana wouldn't have taken off, right? So you're
Yeah.
basically
So
believing in the software quality.
so it's simple but it's fat.
Yeah,
Is that it?
yeah.
And then rollups tiny but complex.
I don't say it's any tiny. Like it's definitely tinier than L1, but
They can
um,
grow to be fat as well.
yeah. For example, like Initia L2s are running the exact same software as L1s, right? So in my terms, it's not any smaller. It's about the same size.
Okay, I think we've talked about a lot of stuff. Is there anything else you want to talk about?
Hmm. I no, a lot of stuff, but I probably wouldn't be able to finish the conversation. So let's call it a day here, maybe.
Yeah, let's wrap it up. Also, tiny little question:
Sure.
why the name NewMetric? Is there a specific reason?
Why the name?
NewMetric, yes.
Uh, like literally, I thought what we were doing is like setting the bar so high that it's like basically literally new metric. I probably should have called it NewMetrics, but same thing. Yes. But these numbers, as an engineer, what I like to do is optimize the shit out of existing software such that it cannot be any faster. That's the goal I shoot for, right? So I figured I kept this name for more than 10 years. Like one day I'm gonna set up a company that's called NewMetric. So I kept it around for 10 years. This is the time. Let's do it. Yeah.
Yeah, I think it's time to wrap it up. Any call to actions if people want to, reach out, use NewMetric, socials, all that stuff?
Uh, I think you will know when we actually go hard on marketing. We are currently more in the research mode, so we don't really pay too much attention to marketing. I'll be honest here. We are too busy building. But one day, I think you're gonna have to use us in some way or another, one way or another. So let's keep in touch.
Anyways, that's good.
Mhm.
Thank you.
Thank you.